Okay. So math 21. We're working on chapter 7 today, 7.1 and 7.2. We will do 7.3 after the midterm. We are looking at the normal probability distributions. So what you need most importantly for solving the shit in this class is how to get to it in StatCrunch. Stats, calculators, normal. Let me open it up and show it to you real quick. You will have a spot to enter the mean and standard deviation. You can pick what we're setting the X for. And you do only less than or equal to or greater than or equal to. I'll show you why in just a second. When the mean is 0 and the standard deviation is 1, it's called the standard normal. And that will be 7.2. That is the Z curve. Where we did remember doing Z-scores a little while back. Like if we wanted to compare the heights of guys and girls, it was not really fair to compare them directly, so we converted to a Z-score. 0 is the mean and the standard deviation 1 for Z-scores. We have a couple options here. We can do standard or between. When it's something besides the normal standard deviation or mean and standard deviation, some more stuff shows up. Where the fuck is it? It's not there. They get rid of it? Oh, you rat bastards. Huh. Oh, that's cold. That's cold, man. It used to have a button where it showed the empirical rule. The 66, 95, 99.7 breakdown. I don't fucking see it. It's not here no more. That's rude. Oh. They're like, nope, you gotta do it by hand. You go F off. So what's special about the normal bell curve? It's a bell curve. Bell curve distribution, which is what we like. This is what we prefer. This means it's symmetrical of about the mean. I should say mean, it didn't say it very well. And it has inflection points at plus and minus 1 deviation. That may not mean a lot to you, but if we look at it real quick, plus 1 deviation and our mean's in the middle. It's right about where the curve, as I'm going to the right, it stops going down and it starts slowly increasing. The steepness is changing. It's where the steepness fluctuates. That's what we call an inflection point. You don't need to know that. It just kind of tells you where where the curve's shifting. Important other things to know about the normal distribution: the area under the curve is 1. 1.00. So this easily shifts to probability. Shifts to probability easily. Because the area is between 0 and 1. So we have portions of the area, we have probabilities less than 1. I already said one of them, it's symmetric about the mean, median, mode. Like a number line, it increases from left to right. And the graph never touches the x-axis. It gets really close to it. It can get infinitely close to it, where you need like a super magnifying glass to see that it's not touching. Because to the naked eye, it would look like it's touching. You guys ready for more? All right. Does anyone need it up longer? Is anyone still writing this? All right. So for a given area under the curve, like between two values, We can say that it represents that the area represents there's two ways of looking at it. A, it's the proportion of the population with the trait or characteristic. And the other way to look at it is if a random individual is selected from the population. Then it's the probability that they have the trait. It showed up. I just didn't click compute earlier. It's still there. Yay. It's handy. I'll show it to you. We're gonna go back in a second. Usually, frequently, the problem usually tells you that it's normally distributed. That the data follows a normal distribution. They'll say it that way. They'll say it follows a normal distribution. But follows a normal distribution. Or they'll say is normally distributed. These mean the same thing. And it never occurred to me that I need to spell it out explicitly that they mean the same thing. But I've had students ask that it wasn't clear to them. Does normally distributed mean it does a normal distribution? Yes. The only options we have are probability is X is less than or equal to something. Probability is X is greater than or equal to something. Or probability is less than or equal to, or it's between two values. The reason why there's no like strict inequalities is because the probability that X equals a specific value is 0. It represents area. And remember, if we treat it like a rectangle.
Can you put the page up, please?
Yep. It represents area, so if it has X equals something, it has, this is a rectangle with a width of 0. It's just a line right there. So we don't have X equals, we don't have X less than falls in this category. X less than is the same, you would just do less than or equal to. X greater than, you would just do greater than or equal to. They don't bother showing them two different ways because they equal the same thing. The equal portion is nothing. Let's look at an example. Make sure everyone's good. Does anyone need it up longer? Okay. So we've looked at the IQ test before, talked about it before. IQ test is normally distributed. It has a mean of 100 for the population and standard deviation is 15. So if we did the empirical rule, I'm just going to show you how it differs. The empirical rule gives us that nice little bell curve. We have 100 in the middle. This is 115, 130, 145. I'll show you how to produce these numbers on StatCrunch in a little bit. And let's say we want to see, let's look at the range between, let's do 70 to 115. So from here to here. So remember, this is 34%. This is 34%. This is 13.5% right there. The area there is all three of those. 13.5 plus 34 plus 34 is 81.5% or 0.815. This is using the empirical rule. We're going to go look at what the normal calculator does. Now let's check this on the normal calculator. Stats, calculators, normal. That's calculator's normal. We're gonna put in our mean of 100 and our standard deviation of 15. We're gonna click on between. And notice as soon as I click on between or compute with other numbers in there, it changed it gave me this thing up here. We'll look at that in a second. We want 70 to 115. This says 0.8186. The probability that 70 is less than or equal to X, less than or equal to 115, is 0.8186. Notice if I click on these two tabs, this thing right here, see on the bottom it does every 20 right here? 60, 80, 100, 120, 140. Well, if we wanted to do the tick marks from the empirical rule, we click on it and it changes to the empirical rule. If I did exactly 85 to 115, I should get 68 because it's the two tick marks, but I don't. I get 68.2689. So this is 81.86%. This is much more accurate. Empirical rule. But the empirical rule is close. Generally, the problems are pretty good about telling you, using the empirical rule. They want you to, they'll say something like that. They'll say, using the empirical rule, what is so-and-so? If it says follows a normal distribution or the data is normally distributed, they probably want you to use the normal calculator. Because the numbers are going to be slightly different. Just they're super close, but they're different enough. Y'all know when you've like done homework on the shit and you didn't round the right direction, it fucking tells you you're wrong. Well, this is a little bit off, more off than just rounded. Not much more, but it's enough that if rounding pisses it off and you do empirical rule rather than normal distribution, it's going to piss it off too. And it may not tell you that you were supposed to use, it may not recognize that, oh, you put in the empirical rule answer. So try to pay attention to what it's asking for. This 70 to 115, I can say it is two ways. A, the proportion of the population. Fuck, can't even spell it. Let's go to the next page real quick. So the proportion of the population with a score with an IQ between 70 and 115 is 0.8186 or 81.86%. That's one way of saying it. Another way of looking at it is if we randomly select a person from the population there is an 81.86% chance. Or 81.86% probability that their IQ is between 70 and 115. Right? Sure, I mentioned this before. I really like how it translates to, like, if you look at the graph for it, we look at people with 100 or below on the IQ, you get 0.5, which is 50%. Half the people you meet are below average intelligence. I like that. Makes me feel smarter than I really am, probably. All right, let's take a look at another example. The weight of giraffes is normally distributed. There's two F's in giraffes, right? It's a weird word. It didn't look right with one F. With a mean of 2,200 pounds. And a standard deviation of 200. So they might ask you to do a couple things on the homework, like draw the table with 68, 95, and 99.7 marks. And then B, shade the area to the right of 2,300 pounds. What does this represent? You know, instead of taking up the whole page, thought I'm going to draw the graph over here, and now I'm thinking that's pretty stupid to try to draw the graph right there. So I could have wrote those lines out and made them longer because I'm not going to draw the graph there. That doesn't seem like a good idea at this point. I know. Save a tree. Not doing it.
It's already cut, right?
It's already cut.
How are you gonna see?
I'm preventing it. I'm not getting another tree cut down for my extra waste.
I mean, they're gonna cut the trees down first.
Yeah, but they're cutting it down because people like me will use it. That's saying they'll cut them down anyways is not the excuse. They cut them down because of me. For me, they're deliberately cutting it down because they know I use a lot of paper. I could do this shit on the whiteboard with markers. I don't think I'd make it as an effective teacher that way.
I was gonna be like, what whiteboard, but there wasn't.
There is one, it's tiny. Some teachers use it. It used to go the full length. You can see the little like drill marks in the wall where it was over here.
I wonder why they came out, because now it looks weird about the other half.
If I can point it out and ruin the classroom for you.
No, I've noticed it the whole time. I just didn't say anything. So that-
Oh, okay.
I thought that was like the new design, you know?
So we got mu plus 1 sigma plus 2 plus 3. Then minus 1 sigma minus 2 minus 3. Now we had mean was 2200 and standard deviation was 200. So this puts this at 2200. And I add 200 as I go to the right. And I subtract 200 as I go to the left. This isn't too bad to do by hand. Because the zeros just, it's like 22 and 2, moving by 2. It's even increments. Those are the 68, 95, and 99%, 99.7% check marks. So this is 68 between those two. 95 there. And 99.7 there. Now they want us to shade the area to the right of 2300. 2300 is about halfway between 2200 and 2400. And we're going to shade over here. And they ask, what does this mean? So the area represents A, there's two outcomes. The homework is probably going to ask you what they both are. The proportion of giraffes that, well, this represents weight. And the numbers to the right of 2300 are larger than 2300. So it's the proportion of the giraffes that weigh 2300 pounds or more. B. It's the probability, the random probability that a randomly selected giraffe weighs more than 2300 pounds. I can't figure out what that is looking at the empirical rule, can I? It's a number, it's a percentage. Because this probability is a percentage. We'll go over and look at StatCrunch in a second. And we'll figure out what that value is. But I want to add one more thing to it. Because I know they ask shit like this on the homework, and I think it's kind of like important to show you. I'm gonna say it two ways to show you the difference. What weight captures 95% of the giraffes? And what weight represents the top 10% of giraffes? These are slightly different, even though the wording is this, just means the exact same opposite. Be a little bit longer, and then we'll switch over and look at this. Okay. So I'm gonna go stats, calculators, normal. We had a mean weight of 2,200 and a standard deviation of 200. And we wanted 2,300 here. And it's shaded the wrong way. I got the wrong sign. There we go. So this is 0.3085, or so that's like 30.85% for B. I want to change that captures 90% to the bottom 90%. What weight captures the bottom 90%? So when you don't know what the value is, but you want the percentage, you can actually change this value. We've been changing this value the whole time, but you can instead choose to change this value, and 90% as a decimal is 0.9. And it tells me 2,456.3. Now, I'm pretty sure when they weighed the giraffe, they're not writing down decimal values. So we could have 2,456, which is right near it, or we could have 2,457. Which one captures 90%? If I round down here like I should, 0.3 would say round down, right? If I round down, I only get 89.97. I haven't actually captured 90%. If I do 2,457, I actually have 90% plus a little extra, but at least we got the 90%. This was 90.0 plus. This was 89.9. So the right answer for the captured 90% is going to be the larger number, which was not the correct way to round. So 90% was exactly 2,456.3. If we're doing the scale, 2,456 only gave us 89.9%. But going up to 2457 gave us 90.00, like 6%. 2457 is the answer we want, even though it's not the correct way around. When I do what weight represents the top 10%, top 10% means I'm getting the portion of the graph that's over here, and I want that area to be 0.10. So if I'm shading on the right, this is going to be probability that x is greater than or equal to something equals 0.10. They will ask you shit like this, and they will be picky like this. Like the 2456, even though it's the correct weight around, doesn't actually get 90%. So if I want to do the top 10%, I'm going to come over here and change this to greater than, so it shades the right. And I'm going to change this to say 0.10. And we get that same 2456.31. But if I go to 2457 this time, I don't actually get 10%. I get 9.9%. So in this case, I want the 2456 because it actually gets 10.02%. So this is like the same question, almost the same question. It's the same parentheses marked two different ways, but this one we want 2456, which happens to be the correct way around. And the top question did not have the correct way around. So you kind of have to check values around it. Go to the, like, if they want the nearest whole number, like I had here for pounds, go to the nearest whole number, check both of them and go, which one of them gives me the actual percent that I need? Because it's not always the direction you should round if you're rounding mathematically. Okay? That's kind of 7.1. 7.2 shifts to z-scores. And rather than being the normal distribution, this is called the standard normal distribution. Have fun, Cassie. So if like we wanted to see like giraffes versus elephants, they're not the same animal, but we could see which one's like larger for its breed kind of thing. I'm not gonna do that. It seems like a lot of work. X equals mu plus z sigma translates to z equals x minus mu over sigma. When you convert it to a z-score, the mean is 0 and the standard deviation is 1. Sometimes they treat z-score like a verb. The word z-score like a verb rather than a noun. It's a number, it's a noun. Like Z score the 2,300 pound giraffe? So Z equals X minus mu over sigma. X was the actual weight of the giraffe. The mean was 2,200. And the standard deviation was 200. This gets us down to 100 over 200, which is 1/2 or 0.5. And now the giraffe is Z scored. Seems like such a weird thing to say, but I've seen it in shit. All right, you guys ready for some more examples? Well, a little more information. Some people are still writing, and be patient. But cold this morning, wasn't it? I was like chilly walking in. Fuck those 8 a.m. classes now. Y'all got the prime time slot. 10 to noon is like the perfect hour for a class. You can get up sort of late, not late, but like not 8 or not 6 in the morning. But you can be done by noon. So you really got like the rest of the day. You go to a movie or whatever, go to work. Usually go to work, right? I don't know, the morning class oftentimes. How many people in here have a job? Not as many as you think, right? A lot of people like, if I ask this in the evening class, like, it's gonna be like 90% raise their hand. They take the evening class because they work day jobs. All right, so a little more information to throw at you. So sometimes the problems will show you things like this. Z with a number here, like Z 0.2. What this means is find the probability that Z is less than 0.2. And sometimes they'll actually, like, it won't have the number there. It won't have this hashtag symbol, it'll just have the number. Sometimes they'll say Z alpha equals like, I don't know, 1.4. If they put the alpha, so this is alpha. Or the fish. When they say the alpha, they want probability that Z is greater than 1.4. I'm not gonna have either of those notations on the test. But homework will do it. Sometimes you'll see it in publications. Like, I don't care for it. It's too lazy. This is much more clear. So we can look up a few of these. Let's do probability, not X, Z. Probability that Z is greater than 0.4. Let's do probability that Z is less than 0.7. Probability that Z is greater than -2. Ooh, let's do between. -2 is less than or equal to Z, less than or equal to 2. Does anyone need a break? It's been an hour. I should let you go pee if you need to go pee. Does anyone need it? Anyway. Nope. All right, we'll keep going. No one wants to get up. That's fine. Let's do it. All right, we're gonna go over to StatCrunch and figure out what these values are. Sure, everyone writes it down first. Stats calculator is normal. The default setup is the standard normal distribution. So I don't need to change the Manning standard deviation. Unfortunately, this doesn't say Z, but it is Z when mean is 0 and standard deviation is 1. So it's important to know that. They didn't make a separate calculator for Z. They're just assuming that you'll be able to say, okay, that's Z. So we wanted greater than 0.4. And I'm getting 0.3446. So I'm writing down. Actually, I'll write down all the decimal places because you never know what stat or the homework is going to want me to round to. I had another one on there that was greater than. It was numbered the third one on the list. I'm going to do that one real quick. I'm going to do. Actually, I can copy these and paste them over onto the side real quick if that helps people. Now I'll change this one to the -2. This was our third one on the list. And I've got 0.977249987. Then we wanted less than 0.7. That's the value we want. That was the second question. So 0.75803635. And finally, if we want between, we gotta come up here and click between. If we click between, we can change both values. We don't have to set them equal to the same value, but this question asks for both of them to be equal. So 0.95449974. So if I write this as a percent with 2 decimal places, it's 95.45%. On the z-score, though, this is plus or minus 2 deviations. So the empirical rule would say 95%. Again, it's close, but it's not identical. In general, in real life, a good rule of thumb to whether you use the empirical rule or like actual calculations. If it's fucking important, like your job is gonna depend on you giving the right answer, don't use the empirical rule. But if you're just trying to get like a rough number, I don't need to get it out of a stats calculation machine. Or figure out how to do statistics on my calculator. Cause the empirical rule is really easy to draw when you have the mean and standard deviation. And you can figure out right from there. So, like, if you have like whole number values for like the deviations. And it's not important, like your job's not dependent on it, you're not gonna kill somebody if you have the wrong values. Use the empirical rule, otherwise use the calculations. We've got a few examples here. Got 4 examples, we'll be done. Yeah, here early today. You guys ready? You manufacture doodads. Don't ask what a doodad is whatever you want it to be. Now, defective items tend to deviate a lot from the mean. So you decide to scrap the lowest and highest 10%. So we're gonna find the z-scores that do this. So those are the things we want to get rid of. We can do them separately. So we could do, this is probability that Z is less than, and we want it to say 0.1. And over here, this is probability that Z is greater than, and we want it to say 0.1. Or you can look at it this way. If 10% is over here and 10% is over here, what percentage is in the middle? Anybody? I've got 10% over here and 10% here. How much percent's got to be in the middle? 80. 10 and 10 is 20%. 100% minus 20% is 80%. We could do the between thing and do less than or equal to Z less than or equal to and put 0.8, and it should fill in both of them simultaneously. All right, let's come over and look at it on StatCrunch. So I'll start from scratch because it's helpful to see it a few times. Stats, calculators, normal. I could do less than 0.1. And it gives me negative 1.28. I'll write that down over here. I could do greater than 0.1. And look at that, I get positive 1.28. If I do between, I gotta say this is 0.80. And it gives me negative 1.28 on the left and positive 1.28 on the right. The reason why they're the same is because it's symmetrical. So it's a perfect mirror, it reflects each other. If you are trying to do this using the tables and trying to do this like stuff without using StatCrunch, you deserve the suffering that you brought upon yourself. I'll tell you that right now. The fucking standard deviation tables, the tables for doing Z's and stuff like that, they fucking suck. They're hard to read. They are a pain in the ass. It's just like pages and pages and pages of fucking numbers with different yeah.
I took the stats class in high school and they made us do it all by hand.
You know the suffering then. That's how it was when I was a student. We didn't have. I didn't take it that fucking long ago either. Like when I was here at COS, it was maybe 15 years ago, not that long ago. A lot of you are like 15 years. I'm fucking barely 18. That's a long fucking time. When you're my age, 15 doesn't feel like that fucking long ago. In terms of technology, doesn't seem like it should be that like grand scheme of things, but no, they didn't have, like, it wasn't cheap or readily available for everyone. We didn't do it. I did the table. Sucks. You know what I'm talking about if you did this. Don't do it. StatCrunch is so much easier. Every semester I'll have one student like will fucking be like doing this and like come up during the midterm and go, Like try to like show me the tables. I'm like, nope, I'm not working with the fucking tables. You brought this upon yourself if you do the tables. Don't do it. Alright, next question. Find the Z-score that represents the 88th percentile. Let's say you took the GRE. Or SAT. GRE is the graduate requirement exam. Like if you want to go to grad school, that's what you take after you get your bachelor's or your last year of your bachelor's, you take this. Depending on what major you're in, you might have a GRE related to your major. If you get the 88th percentile on the fucking GRE in your major, you're a goddamn badass. That's some bad. I was like below, like around 60%. I don't remember if it was above or below.
Is it, that's
Mine was the GRE in mathematics. Mathematics covers a lot of fucking topics. And for you to learn them all as an undergrad, like for your bachelor's degree, you would need like 180 units.
oh, wow.
All your regular education, and then there's like all the applied math courses, all the theoretical math courses, all the computer, like how you would do it in a computer. All of that shit showed up on the GRE exam. So the only way someone was doing well on that is if they took way too many fucking classes. 88, how did percentiles work?
They add up,
They what? Say it.
I mean, percentiles, like they add up to 100.
Percents, yeah, add up to 100. The term percentile means a very specific thing.
Oh.
We were doing these in the box plot area.
To that percentage.
It means up to that percentage. So 88% or less. So we're gonna do probability is Z is less than, and we'll do 0.88. We want standard, we want less than, and we want 0.88. And we get 1.175. So Z equals 1.175 is the Z score that represents that. Ready for one more? I think we can get away with doing one more, and I'll just do it two different ways. All right, you guys ready? Human gestation period. We like to say it's 9 months, but like in terms of days, gestation is how long you're like in the womb before being born. Like how long you're a baby before you're born. That's what gestation is. So we normally like, well, you're a baby for you're like in the womb for 9 months, but like in terms of days, the average is specifically 266 days. And there's a standard deviation of 16 days. So that's quite a range. So let's look at a few things. We're gonna look at A, the percent. Where gestation is more than 270 days. Like very preterm babies. Are less than 224 days. Which is like 7.5 months. What?
How did you get the 60 days again?
I didn't fucking get them anyway. It was like fucking looked up. It might have even changed. I doubt it, but like, I don't know, let's Google human gestation period. Well, you asked, now we're getting it. Well, it changes, like the overall population is gonna be one thing. This should be it. That is not it. So it's an article, it did fuck give the information. Fuck off. They got it from somewhere. This one says 272 days with a standard deviation of 9 days, but it was for women native to the area of study. So it was a regionalized thing. So there are things, there are just factors that contribute to what changes it. I imagine the climate, temperature, and shit like that would have a huge impact. But let's just say it's this. So we want to see what percent are preterm. What gestation period captures the inner 90%? And D, what are the z-scores for those? Or the inner 90%? I'm going to tell you right now on C, they're going to give us something like this. Wait, no, it'll be more like this. 90% is like here. But it won't, like, it will not be on a decimal day. Or it'll have like a decimal. We don't want like 0.3 days or some shit like that. So we want to round to the closest, or round to the appropriate day. Round to the day that's outward. So closest day that's out of that range. You'll see that when we get to C. That way it'll be a little bit higher than 90%, but it's still the 90%. If I want more than 270 days, what am I actually looking for here? What's the probability thing? What does more than mean? Greater than. Does the alligator open towards the X or away from the X on greater than? Towards the X. On B, we're looking for less than, so it opens the other way. On C, we're looking for a between thing, where this equals 0.9. And we got to take into account that we need to round to days that are outside. Z-score, we won't bother. Just leave as is, don't shift the days. Or D, for Z-scores. And add the word pregnancy up here. Because most people know what pregnancy is, but not everyone knows what gestation is. All right, you guys ready? So we go stats, calculator is normal. We had a mean of 266, was it? And a standard deviation of 16. So we'll put those in and then we'll look for more than 270 days. .4013. In terms of percent, we got to move it 2 decimal places, 40.13%. If we want to do the preterm babies that are less than 224, oh, that's barely anything, 0.43. Look how small that is. After we move 2 decimal places, 0.43. Was it 224? Yep. And that's percent, 0.43%. Next, we want to do between, and we're doing the inner 90%. So we're going to change that to say 0.9. And we're gonna click compute. So I'm getting 239.7 on the left. And on the right, I'm getting 292.3. On the left side, I want to round down because I can't have 230. We're going to do it to a full day. I'm rounding away from the region. So 239 here. And here I'll round up to 293. So you'll see if I change this to 239 and 293, I should be just a little bit above 90%. Not much. So 239 and 293. So they had 239.7, 292.3. Here we're going to round down to the 239. Here we're going to round up to the 293. And finally, we got to do the Z-score. Now, we could go through and figure out what those values are and convert them by hand, but fuck all that. Work smarter, not harder. Z-score has a mean of 0 and a standard deviation of 1. If I put 0.9 right here, I can get that same 90% and get the Z-score straight out the gate. None of those calculations. Screw doing all that. Z-scores for the middle 90% are between negative 1.645 and positive 1.645. Any questions? All right, let's call that a wrap. You're free to go.